Hi everyone, welcome back to my control systems lecture. In this lecture, I'm going to explain an example which I have given during one of my lecture. And then this is regarding to a second order systems here with a plant transfer function 14 over s plus 6, and we are about to evaluate this transient and also the steady state's performance. The usual calculation steps applies over here, whereby first of all we have to find out what is our closed loop transfer function, and then this will be given by gs over 1 plus ghs, and because of the unity feedback systems, my hs will be equals to 1. And by substitutions of this plant transfer function and rearranging of this term, we will get 14 divided by s squared plus 6s plus 14. And then we will have to compare the coefficients with the standard second order transfer function with the zeta and omega n, so that we can identify the response type. So by comparing the coefficients, we will be able to get the omega n squared equals to 14 and get omega n equals to 3.7147, and then 2 zeta omega n will be equivalent to 6, and then finally we can get our zeta value to be 0.8 something. Because of the zeta value is actually less than 1, and we can be sure that the system is actually at the underdamped response. That means we will have some sort of the oscillation. However, because of this magnitude 0.8 is actually very close to 1, hence we will say that even though the system exhibits underdamped response, but the response will be looking something like this, whereby the peak overshoot here it will be actually quite low. So since this is an underdamped response, we will apply the formula to calculate the settling time, the rise time, and also the maximum overshoot. So settling time is given by the approximation of 4 times of the system time constant, where the system time constant tau is approximately equals to 1 over zeta omega n. Therefore, by having 4 tau, we have 4 over zeta omega n, and this will be 4 divided by 0.8076 multiplied by 3.7147, which are the value of the zeta and omega n respectively that we obtained earlier. And then the rise time will be equals to pi minus beta divided by omega d, and pi and omega d will be these two values respectively. And then maximum overshoot will be following this formula. And next, I'm going to show how do we obtain all these values, and I'm going to use the MATLAB to aid my calculation. And of course, in the examination, you are expected to use the calculator. Just make sure that you are familiarized with the operation of the calculator in determining all these values. Okay, so let's swap to MATLAB. Here are the commands that I've typed in MATLAB to get the solution for the maximum overshoot, settling time, and rise time. Basically, I'm just defining the G and T here so that I can generate the step response later. And then as per our calculation earlier, omega will be square root of 14, and the zeta value denoted by ZT here will be the 6 over divided by 2 times omega n. And here we will apply the formula exponential negative zeta pi divided by square root of 1 minus zeta square multiplied with 100%, I will get my maximum overshoot to be about 1.48%. Next, this is the approximation to calculate the settling time, which is 4 over zeta omega n, and then this settling time will be equals to 1.3333 second. And then my rise time will be pi minus beta divided by omega d, where this beta will be inverse tangent of square root of 1 minus zeta square divided by zeta, and omega d is actually my omega n multiplied square root of 1 minus zeta square. Just a friendly reminder that this beta here must be in terms of radian because of the pi in front. And then I will get my rise time to be equals to 1.11 second. So let's check by generating step response. Okay, now we have this step response generated from the MATLAB, and let's compare with our answer. And then I am going to show you also something that you should read and also something that you shouldn't, because not all the system's parameters, especially the transient response characteristics, can be accurately captured by using the MATLAB, because MATLAB follows a set of predefined formulas to identify the points, but it may not be agreeable with what we have calculated. So let's see here. Now, first of all, we have calculated my maximum overshoot to be 1.48%, which is here, and that's correct. Okay, good. Now, the next thing that I want to look at here will be the rise time. Rise time here is actually about 1.12 seconds, but in here it is actually showing 0.661. So the obvious reason why is that because MATLAB actually shows the rise time that actually determines from 10 to 90%. But our calculation based on this formula, which is pi minus beta divided by omega d, actually determines the rise time starting from 0% until 100%. Therefore, you will see that actually these two answers are not agreeing to each other. So if you want to really verify whether your calculation is correct or not, what you can do here is to locate the point where the system hits 100% at its first time. So let's try it here. Now, when the system grows from 0% to 100% for its first time, you can see now is that we will actually reach 1, okay, exactly when the time is equals to 1.12, which agrees with what we have calculated. And also you'll find that it's quite surprising that now my settling time appears before my rise time, which is not usually the case. And also our settling time has been approximated to 1.3333 seconds, which looks actually correct here. And now why is it happening that the MATLAB is actually detecting the settling time with 1.01 second? Simply because MATLAB actually reads the settling time from minus 2% and plus 2%. It will be the point, the first entry into this region. That point will give you the settling time, which is why the MATLAB is actually detecting the settling time as early as 1.01 second. So that will be all my sharing for this example. So I hope you can learn something on how do we actually read the results of the MATLAB and try to avoid some of the discrepancies, okay, between what we have calculated and also what is being shown in MATLAB. Thank you very much for watching. Bye.